Hello everyone, this is Miss Berlin, and on this lecture video we will have the 20 items physics exam warm-up review part 1. Hopefully we will have time to make the part 2, but the following is true about charging by induction. So this one, is it A? It requires direct contact between objects, B, C, or D? Take your time and try answer. You may pause this video, So the correct answer for this is letter C. The neutral object develops a charge opposite to that of the inducing charge because induction causes charge separation, which results in an opposite charge on the neutral object without direct contact. How about number 2? Again, you may pause as you try to read and then as you try to answer. So for number 2, when a rubber balloon is rubbed against wool, the balloon becomes negatively charged. Why? You may pause. Is it A, B, C, or D? The answer is letter D. The balloon gains electrons from the wool. The reason for this is that rubbing transfers electrons from the wool to the balloon, which gives it a negative charge. For number 3, why do metals conduct electricity while rubber does not? Again, pause. Is it A, B, C, or D? The correct answer is letter B. Metals have free moving electrons. This is because metals that have free electrons are allowed for charge movement, while insulators like rubber, they do not have free electrons. Now, next one is number 4. If the distance between two charges is doubled, what happens to the electrostatic force? Is it A, B, C, or D? The answer is letter C. So this one is because according to Coulomb's law, the force is inversely proportional to the square of the distance. So it should be reduced to 1/4. Next one is number 5. If one charge is doubled while other remains the same, how does the force change? Is it A, B, C, or D? The correct answer is letter A. It doubles because the force is directly proportional to the product of the two charges. How about number 6? Where is the electric field strongest around a point charge? Again, where is the electric field strongest around a point charge? A, B, C, or D? The correct answer is letter B, closer to the charge. This is because the electric field strength is inversely proportional to the square of the distance from the charge. I want you to review the formula for electric field for this so you are already familiar with direct or inverse relationship, right? So that's it. For number 7, which of the following statements about electric field lines is true? Is it A, B, C, or D? The correct answer for this is letter C. They never cross because the field lines do not cross because each point in space has a unique direction of the field. Okay? So the other answers seem to have interlopping of field lines, but when I talk about field lines, they have specific paths, so they never cross, they never create loops. Now, for number 8, which of the following best defines electric potential? Is it A, B, C, or D? The correct answer is letter B. The work done in bringing a charge from infinity to a point per unit charge. For number 8, we mean to say that electric potential is the energy per unit charge at a point in an electric field. That is one way to define electric potential. Next, number 9, what happens to the electric potential as you move closer to a positive charge? Again, what happens to the electric potential as you move closer to the positive charge? The correct answer is letter C. It increases. Because positive charges create higher potential regions that are closer to them. Number 10, what happens to the capacitance of a parallel plate capacitor if the plate separation is doubled? Again, what happens to the capacitance of a parallel plate capacitor if the plate separation is doubled? Is it A, B, C, or D? The correct answer is letter B. It is reduced to half because capacitance is inversely proportional to the plate separation. And if it is inversely, then therefore it will be reduced to half in fraction form. Now next, number 11, what effect does inserting a dielectric material have on a capacitance of a capacitor? So is it A, B, C, or D? The correct answer is letter B. It increases the capacitance. Whenever you insert a dielectric material, it will increase the capacitance or the ability to store the energy or electricity. That is the purpose of capacitor, right? To store uh, electricity, right? So whenever you insert a dielectric, it enhances that capacity. Next, number 12. Which of the following correctly describes the relationship between current, voltage, and resistance? Is it A, B, C, or D? The correct answer is letter A. That is voltage equals the current multiplied to the resistance. For you to understand this, we have here the following triangulation of the Ohm's law. So as you can see, the only match expression is the product of current and resistance is equivalent to the voltage, the first one. Next, number 13, what happens to the resistance of a wire if its length is doubled and its diameter remains the same? Is it A, B, C, or D? Again, you may always pause, and as you read the problem and as you try to analyze, you may always pause the video. Okay? So the correct answer for this is letter A. It doubles. This is because resistance is directly proportional to length. So if it is directly proportional, then it should be doubled, right? Since the length has been doubled, so meaning to say they will experience the same phenomenon. When one variable has been doubled, the other variable will also double. Next, number 14, why are metals good conductors? Again, why are metals good conductors? A, B, C, or D? The correct answer is letter A. They have free moving electrons, which insulators do not possess. Next one is again, conductors on the spot allow electrons to move freely, which enables electric current. That is one of the behavior of electrons on a conductor. Next, number 15. Oh my gosh, I already showed the answer. But for this one, number 15, a 10 microcoulomb, the mu sign here is this one. This one here. This one is a micro, which means micro. So on this part, we have a 10 microcoulomb charge is placed in an electric field of 500 Newton per coulomb. What force does it experience? So the answer is, of course, 50 Newton. So how did you solve this one? The first thing that you need to consider in solving number 15 is that the uh, total electric field will be equivalent to the total charge. So you just need to express the 10 microcoulomb here. The 10 microcoulomb is expressed as this one, as 10 raised to negative 6, this one, 10 raised to negative 6, then multiply that on the electric field. Again, the total charge of the electric force is equivalent to the electric field, which makes it 0.005 Newton or 50 Newton. You just have to multiply that. This one, multiply the given values, the microcoulomb here, the microcoulomb here, and then the electric field. That's it. Next one is number 16. Which of the following best describes why grounding is important in electrical circuits? Why grounding is important in electrical circuits? Is it A, B, C, or D? The correct answer for this is what? The correct answer is letter B. It removes excess charge. So grounding provides a safe path for excess charge to dissipate. When we talk about grounding, it means burying the electrical circuit in the ground. So that's why some countries have their electric lines under the ground to dissipate the heat. Okay. Next, number 17. If three resistors are connected in series, how does the total resistance compare to the individual resistances? Is it A, B, C, or D? Now we are pertaining to series, not parallel. So if we are pertaining to series, the answer would be letter A. The total resistance is greater than any single resistor, of course, because in series, the resistances add up. They add up. You do not get the inverse of that, but just add them as a whole number, just like this in our rational. Now, next one is number 18. Which condition will result in maximum electric flux through a surface? Is it A, B, C, or D? The correct answer for this is letter B. The surface is perpendicular to the field. Remember that in electric flux is maximized when the field is perpendicular to the surface. So we are being asked with the maximum electric flux in this problem. So we also need to keep in mind that for an electric flux to be maximized, it should be in a perpendicular to the surface, following our equation on electric flux equivalent to the electric field multiplied to the product of the cosine that is perpendicular, where the theta angle of 0 degree leads to maximum flux. That is what we mean by this. Next, number 19, if the net electric flux through a closed surface is zero, what can we conclude? Again, what is electric flux? I have discussed this previously already. Electric flux is the number of electric field line that is allowed to pass through on a point charge. So, that is what we mean here. If in a closed surface, what can we conclude in the total electric flux or to the net? Net means total. So is it A, B, C, or D? The correct answer is letter A. No charges are enclosed in the surface. Why? Why is it that no charges are enclosed in the surface? It is because the Gauss law states that net flux or total flux is proportional to enclosed charge. If flux is zero, therefore the total enclosed charge is also zero. Remember the equation for this one is the electric flux is equivalent to the total charge over the electric permeability. That is the equation. So both are in numerator. So therefore, if the closed surface is zero, then the flux is also zero. Okay, next, Number 20, how much work is required to move a two-column charge through a potential difference of 12 volts? So we have already the solution. The correct answer for this is 24 joules. So our equation, whenever we are asked to find the work that will move a charge to a potential difference of 12 volts, the equation is that work is equivalent to the charge multiplied to the voltage. So therefore, the work is equivalent to the charge, which is 2 coulomb given the problem, and then the voltage of 12 volts. Multiplying that, you will have 24 joules as for letter A. That is how you solve the work given the coulomb and the voltage. Thank you so much. That concludes our 20 item warm up review for the physics.